Jai Shri Ram to everyone. I am Samprita Kulkarni from Sri Venkateshwara College of Engineering. Today we are going to learn solar radiation calculation problem. This presentation details the calculation of the angle formed by the beam radiation and the normal earth titled gland plate. We will dive into the steps involved utilizing location, data, time, and the gland plate's orientation to determine this crucial angle. Let's see the problem statement. So calculate the angle made by the beam radiation with the normal to the gland plate. The gland plate is titled at 30 degrees from the horizontal and points 30 degrees south of east. The location is New Delhi. Latitude is 28 degree 35 minutes at north and longitude is 77 degree 12 minutes at east. The time is 11 a.m. IST on 1st June. The standard Indian Standard Time, that is known as IST, longitude is 82 degree 30 minutes at the east. So we need to calculate the angle made by the beam radiation with the normal to the gland plate. The gland plate orientation. Firstly, we have to understand gland plate orientation. So the gland plate orientation is titled at a 30 degree as given in the problem statement from the horizontal. This title angle is crucial for determining the amount of solar amount for the radiation receives. Title angle is 30 degree at the south of east. So location information as given in the problem statement, the calculation takes place in New Delhi. It's in India with the specific coordinates. Coordinates are 28 degree 35 minutes at north and this is the latitude and 77 degree 12 minutes at longitude. These are the listed here. So date and time. This is also given in the problem statement only. The time of the calculation is 11 a.m. on the June 1st, 2023. This is the specific time of a date significantly impacts the angle of solar radiation. That is, the date and times are listed here. Standard time zone. The standard time zone for India, known as Indian Standard Time, that is known as IST, is defined by the 82 degree 30 minutes in east longitude. The standard time is used for all of the India, regardless of the actual longitude of the particular location within the country. So standardized time zone longitude is 82 degree 30 minutes at the east. So now calculating solar zenith angle. The solar zenith angle is the angle between the sun rays and the vertical at a given location and time. It is calculated using the latitude, declined angle and hour angle. Latitude is given that 28 degree 35 minutes in north and declined angle is 23.45 degree for the 1st June. It is given. So our angle we need to calculate. We need to multiply with the 15 degree and differences between the given time and the 12 p.m. of the day time. So this is the our angle and solar zenith angle will be calculated using this formula. So we get 39.2 degree. So calculating solar azimuth angle. So the solar azimuth angle is the angle between the sun projection on the horizontal plane and the true south. So it is calculated using the solar zenith angle, latitude and declined angle. Solar zenith angle we have calculated in previous slide, that is 39.2 degree. So latitude is 28 degree 35 minutes at the north, it is given in the problem statement, and declined angle for the 1st June is 23.45 degrees. So the solar azimuth angle is calculated by this formula and we will get the minus 7.8 degree. Calculating beam radiation angle. The beam radiation angle is the angle between sun rays and the normal to the gland plate. It is calculated using solar zenith angle, solar azimuth angle and the tidal angle azimuth angle of the plate. So solar zenith angle we have calculated 39.2 degree. Solar azimuth angle also we have calculated in the previous slide, that is minus 7.8 degree, and Titan angle is given that 30 degree, and azimuth angle is 30 degree south of east. It is also given. So beam radiation angle we have to calculate with this formula. Then we will get the 20.5 degree as the beam radiation angle. Comparing beam radiation angle to the gland plate orientation. The beam radiation angle 20.5 degree is less than the tidal angle of the plate, which is given as 30 degree. This indicates that the sun rays are hitting the plate at the angle less than the plate's tidal angle. So, solar radiation is the angle which is sun's rays hit the gland plate is important because it affects how much solar energy in the plate plate can absorb. Okay, the tidal angle is the tidal angle of the gland plate is designed to optimize the amount of solar energy that the plate of the can absorb. Uh, Conclusion. Totally the problem's conclusion is the beam radiation angle 20.5 degree, which we are calculated, which is less than the 30 degree, which is the tidal angle of the gland plate, suggesting that the gland plate is not optimally positioned to receive the maximum solar radiation. Beam radiation angle is 20.5 degree. We have calculated. This is the answer. This is the solution for the problem statement, and which is given by problem statement only. Tidal angle that is 30 degree. That's all for this video. Thank you.